welcome back, everyone. Our next segment is going to look at a very important aspect of value creation in the mill, flour blending and premix systems. Our first presenter is Mr. MILAN SHAH from Alapala. Mr. MILAN is a mechanical engineer, graduated from the prestigious Bristol University in England, and has over 20 years of experience in the milling sector. That's not counting the many years growing up with the milling family in Kenya. He now lives in Istanbul, Turkey, where he serves as technical director for the Alapala Makina Group. In keeping with our theme of systems aimed at increasing customer satisfaction with our flour, MILAN will be introducing us to flour blending and premix systems provided by Alapala. MILAN Baisan, over to you.
Thank you, Peter, and thank you, Mariam. I will start, as Peter said, premixes and flour mixing plant. And also this presentation relates to the previous presentation by Mr. Salim. So that shows you more insight about the premixes and all that, and how those premixes can be added into the mill in the blending systems. So why this is just a preface of what I'm going to talk about. Why we blend flour, because of variability to obtain consistency. Principles of blending applications. Flour blending systems, I will talk about the two types of systems, which is batch and continuous. Premixes, where Mr. Salim has given an excellent presentation about premixes, but this is a very short one showing how premixes are added into the flour mill and in the blending systems, and then the conclusion. You will see also on the screen that there is a process flow showing in a mill where the blending systems come, that is number 5. Okay. So why do we blend flour? And how many different variability factors do we face? So the first one I'll talk about is the wheat. A possibility of several origins from different geographical areas with different weather conditions and stratification during transport. This continues into the storage silos and the dirty wheat bins in the mill. In the previous presentation, Michael Albers spoke very well about the cleaning of wheat, and so that also relates to this one. How many different variability factors do we have? Number 2, in the flour. The same wheat which we use will see a variable passing into the mill and then into the finished products. This is inevitable. So if we don't do anything about it, that variability will pass into the finished product, which are sold with a maximum and minimum specifications, which are given by probably bakers or the end user. How many variability factors do we face in the process? So the cleaning and the tempering, the variation in the actual milling process, and which leads to the storage of in the bins of the flour. So the various bins, so you have a variation there also in the flour bins. So consistency. How do we get this consistency? So when we look at you will see the purple line, which is the target value, which we will call as 1 SD. And then we have the upper tolerance, which is a +1 SD, and we have the lower tolerance, which is a -SD. So the ideal coefficient would be 1 SD, which is shown in the maroon line. Many bakers, especially industrial bakers, would pay a premium for this kind of a consistent flour. This is a 24-hour laboratory analysis on a certain flour. And you can see from here, from the graph, that over a 24-hour period, the variation in the protein, the ash, and the moisture. And this is talking about the same flower. As Peter asked a question previously about the flour coming in from various millers into the bakery. So how does a baker minimize this variability? So for example, we have mill A and we have mill B, and you can see the differences in the curves of the variability of the two types of flour. So when we blend these two types of flour, when the baker blends these two types of flour, he gets a stable variability. It's not ideal, but he gets very close to what he wants. So to give you an example, here is a flour specification from the UK, from a bakery flour in the UK, where we have a moisture of 14% plus minus 0.6%, a targeted protein value of plus or minus 0.2%, water absorption target value plus or minus 2%. Ash is not considered in the UK. A falling number, 250 seconds, plus 50 minus 0, resistance, and extensibility. This is difficult, without blending. To obtain these specifications is difficult without blending. So what happens when we don't blend the flour and we just take it from the flour bins and straight into the packing? So you can see that we have 4 bins there with the flour, 10%, 10%, 12%, and 14%. And the target protein value we want is 11.5%. So if you look at the curve where the target value we have indicated at 11.5, and the under and over, which is a huge gap. So if the flour is under, is below spec. If it is over, we are losing money. So with homogenization, we try to reduce that gap. So we get more or less to reduce that variability. So we're getting closer to the required spec. In the mill process, with the individual type, each flour is weighed into a mix bin and then thoroughly mixed before bagging. So with this, we almost try to eliminate the variability, as you can see from the curve. By blending, we can effectively remove this by using online measurement and correcting the mixed components to maintain a consistency. Blending systems. What do they consist of? They consist of a mixer, microfeeders for additives, improvers, and micronutrients, as Mr. Salim has talked previously. And here you can see a simplified flow sheet showing how we mix the flour with the microfeeders and all that and then going to the bagging from a bin. Now, here, this is an interesting scenario where the next speaker will speak about the whole wheat or whole meal flours and how do we do this in a mill. So by adding an additional second mixer, we can produce whole meal or whole wheat flour by adding the pollard and the bran back into the flour. And again, we can also add the micronutrients as required. So we have two types of blending systems, which I said in my preface. We have the volumetric system now, which is a batch type system, where we use a paddle mixer with microdoses for the additives and the micronutrients. And you can see from the flow sheet that we have the bins, we have the micronutrients, and we also have a possibility to add whole grains or whatever is required for the flour. And this is a typical example of a paddle mixer. Mixing time going up to 90 seconds on dry products. So this is what we normally use for the batch blending systems. What is the benefit of a batch blending plant? This is an important question. To produce the base flour in a mill, to be able to deliver finished products just in time to the customer, flexibility to change production schedule according to an immediate request, to be able to deliver enhanced products for profitability. So here you can do small batches, maybe a couple of tons, where your customer requires. Economical advantages. So there's a high flexibility during production because it's a batch system. Serving the customer's requirements, so we can have smaller batches. Improve productivity with smaller batches. Consistent quality of the finished product with reduced variability, and enabling the mill to target a wider range of customers. The second system is the continuous system, using an inline screw feeder with continuous weighing units and using a continuous mixer or homogenizer. When we talk about screw type feeders, these are tubular screw conveyors with variable frequency drives. So they work on a volumetric basis. And then when we have the hopper, the receiving hopper, that is on load cells, so that controls the VFDs on the tubular screws. And these are then, with the microdosing, fed into the continuous mixer. This we use for longer runs or longer batches or continuous batches, where you have one customer who requires a continuous specific type of flour continuously. And these are some examples of continuous mixers, courtesy of Mix SRL we work with in Italy. These are all stainless steel. And this is just to give you a small insight into the discharges of the flour bins, which we have in a mill. So we have a simple screw discharger. We have a vibro discharger, which is probably the most preferred system at the moment. And we have the double drum dischargers, which I don't see much being used much these days, but mostly we see the vibro discharger being used. The interesting thing here is the differential dosing scales. These are ideally suited when you want a more accurate dosing of the flour from the bins. And also when a mill has return flour and which you want to slowly bring it back into your fresh flour which you have milled. So these are ideal for this, and these work on a loss in weight principle. Again, this is a courtesy of Imeco, who we work with. And here are some examples of the microdosers. We have on the left-hand side the loss in weight, or as we say, the loss in weight mixer, and then we have the volumetric mixer on the right-hand side. So these are ideal for your batch system or for your continuous systems of mixing. No, okay. We have to go back. For continuous mixing, where we have a same recipe for longer runs, for a smaller number of components, and continuous flow solution, which is logical because we have a continuous run, a longer continuous run, and precise dosing and proportioning of the additives. So you have a consistency of flour coming on a continuous system on longer runs. And of course, as we talked previously in the previous sessions about the optimization of the extraction in the mill. So what is happening here on that? Not only wheat flour, many other cereals like seeds, rye, oats, buckwheat, soy, sunflower, etc. are widely used in the formulation of baked goods. Basically, these are in the artisanal bakeries and all that. So industrially, they are added in base flour as premixes for the production of a wide range of bakery products and pastry products. The advantages of premixes, they contain improvers, emulsifiers, colorants, enzymes as a single component. So it's a less headache for the baker. As I said before, the premix is literally defined as a mixture of foods, including additives intended to facilitate or simplify the production of baked goods, compensate for the fluctuating processing properties of the raw materials, and influence the quality of finished products. The advantages of this is variety of premixes we can get already premixed, convenience, reliability, and of course, consistency. So not only saving from preparation time, these ready mixes have the advantage of eliminating ingredient selection, so less hassles for the bakers or headaches for the bakers. Obviously, there are arguments regarding this, but let's say most bakers would rather have a premix, so there is no question of errors in their staff or the operators of the mixers and all that when they're adding these premixes. And in conclusion, we have a functional consistency of finished products, marketability, so small lots for individual customs, and a better customization, profitability for the mill operation, reduced variability in key quality descriptors like protein, ash, and so forth, reduce cost to the mill of maintaining those quality targets, enhanced possibilities of quality management. So this gives you an overall perspective of mixing plants in a mill. And obviously, a lot of the mixing plants are tailor-made to customers' requirements. In some mills, we have 3 or 4 different mixing lines making different quality of flours for different customers. So it is basically on the requirement of the customers that we design these mixing or blending plants to the customer's requirements. Thank you for your attention. I hope I've given you a better insight as what Alapala sees the mixing plants as and what we offer in our mills. Obviously, this was a very short and not in depth, because mixing plants are normally tailor-made to the customer's requirements. Thank you. Thank you for attention.
Thank you, Milan. There are three questions for you that I'd like to put to you now. The first is, what in your opinion is the minimum size of mill that you consider flour blending? It seems like rather an expensive addition to the mill.
What we see, Peter, is that for the smaller mills, when we are blending the flour, let's say mills less than 100 tons per day, right? I'm talking about these what I call the smaller mills. And generally what we do, because mixing plants are expensive, inline mixing plants, either batch or continuous. And what we see and what we have devised is a mixing screw, which is based like a paddle. The inside, the flights are like paddles, and they are mixing screws. So these are quite enough for small quantities of blending of the flour. So we can have the microdoses and also take the flour from 2 or 3 different bins, because the smaller mills, they probably only produce about 2 types of flour.
Okay, thank you very much. The second question comes from Anthony, and he says, how can we best reduce the failure of additive dosing machines during milling operations, as it is assumed that some of the additives contribute to that because of maybe their moisture levels or moisture absorption in the atmosphere?
Well, the first answer for my answer would be that you should be storing the additives in the right place, cool, dry place, so you do not have this lumping, as we call it, in the additive. And in the new microdoses and all that, we do have what we call an agitator, which is like a lump breaker, which is also acts like a small mixer inside the dosing machine. So that gives you a uniform mix and dosing into the flour.
Thank you. The next question is from Chandrina Pelicano, Mabuhay, and she asks, how do you manage the cleaning and sanitation maintenance of premixes with sugar, salt, milk, chocolate powder, etc., using the batch mixer?
It's a good question. What we normally do, and these are all millers have different tricks to do this, which they've learned and experienced over the years. But generally speaking, is we flush it out with a little bit of flour.
Okay. From Khalid Al-Hazza, the question is, does mixing the same kind of flour in a mixer without any additives help to improve the quality? And does it have an effect on the water absorption rate?
No, the mixer actually does not do much to the flour. It's just basically homogenizing the two flours. So it does not actually have a mechanical impact on the flour. What it could help, and at times what happens is that we can aerate the flour in a mixer.
Okay, thank you. And the last question on the list so far is from Abdul Karim Al-Ahyan. Good morning, Abdul Karim. How do you tackle the traceability topic in a premix plant, considering product/lot identification to prevent any human mistake and keep transparency in front of the end user?
Basically, in a premix plant, the process of making a premix is a little bit different as what we are talking about adding additives into a flour mill at the moment. So when you're actually buying premixes, these are made under conditions by the manufacturer where the consistency, the quality is controlled by the premix manufacturer. But on the other hand, when we look at it in the flour mill, the utmost attention has to be paid that the dosing machines are set and adjusted right. So for example, for flour fortification, you need 200 grams per ton of flour. So you need to have the right adjustments and that you are dosing correctly the right amount of premix into or an additive into the flour.
Excellent. Thank you very much. And the last question that we have is from Ramiz Fadil. Is it better to put improvers in the packing or in milling?
It's better to put it into the milling because when you're milling the flour and you're adding the premixes and mixes, the micro ingredients into online, so they also have a time to interact with the flour in the bins when they're resting, when the flour is resting.
Okay. Well, thank you very much indeed, Mr. Milan, for your presentation.
Thank you.
Staying with this same theme, it gives me great pleasure to introduce you our next speaker, Mr. Peter STRIEGL. Peter is one of the brightest young rising stars in the milling engineering industry. He joined the Buhler Group in 1998 after graduating from the Swiss Milling School as a milling technologist, and since 2015 has headed up the business development team in the wheat and rye division of Buhler's headquarters staff in Utzlin, Switzerland. Peter's paper is entitled Flour Blending and Mixing Solutions with Online Control and Traceability. Create value to your flour. The floor is yours, Peter.
Well, Peter, thank you very much for your very kind introduction. So very warm welcome once again as well from my side, and I'm just following up on the topic of Milan before. So flour blending obviously is one very important part of our whole operation in a flour mill. We were talking a lot this morning already about consistency. Consistency obviously comes when you already blend your different wheat together, but still there is an issue afterwards. And with a flour blending or mixing system, you can further improve the consistency. But this is of course important for the industrial bakeries. However, there is a lot of other market all around, and we heard as well this morning, for instance, from Salim about customized flour. And to produce that, we obviously will have a problem if we have to do all that in a flour mill, because we need then first to have the dampening time. We need to wait till it's ground. And to produce all these, even as well, just in time, is creating a lot of issues. So here really a blending system can help. Then we have seen as well this morning, there is a wide range today of different products which the market requires. And as I said, to produce all that during the grinding process, this really is an issue. Then usually wise, you have diverse market. You have probably large industrial customers, but you have as well the small artisanal bakeries, or even you want to produce something for the home bake market. So there are as well smaller batches needed in your production. And now the mixing system comes in place. It helps to reduce the costs in your operation, because you don't need to produce so many different kind of grists in your mill, and you don't need so many flour bins then at the end, because you don't need to store all of these different products in your flour silo. You just take out the products out of your bins and you mix it together to the next one. Then when we look from another perspective, from the baker's point of view, they obviously will as well ask you to produce something special for them. And they obviously will as well look into all the different parts of the world, what is available, and try to actually ask you to provide them the flour for their different type of products which they want to produce. But there are as well other markets. We heard about the ingredients market. So if you want to produce these premixes, which can be added afterwards, that's of course a completely different requirement. A different requirement is as well the home baking market. If I am, as a customer, want to look for convenience, a ready-made mix, for instance, for a cake or for a special bread. Especially during this COVID-19 crisis, a lot has been, of course, a big boost for that, and therefore we have these sort of products as well available, and a big demand for it. So you see, there are various reasons why we can think about an investment in a mixing plant. Now, when we look at the different solution, basically we see three different possibilities, or we have three different possibilities. First, the very simple one, the continuous volumetric blending system. Usually wise, fixed to a tubular screw conveyor, we have a frequency drive where we can adjust to a certain extent the volume or the amount I want to blend from different type of bins. We can add as well some other additives, but with a certain accuracy only. Then we have the gravimetric continuous mixing with the lost in weight scales, where we of course can already increase a lot the accuracy. And then on the right hand side, you see the batch mixing, which is obviously giving us the highest accuracy. But now the question is, when should I actually apply which type of blending system? And I try to put this in a graph here. So on the vertical arrow here, you see the batch size and the production volume or production capacity. And on the horizontal line is the number of components or additives, then the amount of recipe, and what I call the mixing ratio. Mixing ratio I could refer as well to the mixing accuracy. So obviously, if I have to produce a very small amount of a product or of a mix, then I have to use a batch mixer. If I have to, for instance, only 2 tons of product to be produced, it will be very difficult on a continuous mixing line, because the continuous mixing line obviously has one issue always at the beginning and at the end of the production run, that the accuracy is not the same as during normal operation. When I have larger volumes I have to produce and a very limited amount of components I want to blend, then the volumetric blending, the continuous volumetric blending, is the right solution. When complexity starts rising in terms of a number of components, but I have still small batch sizes, then still the batch mixer is the right choice. And as you heard as well from Mr. Milan before, if you have longer production runs, then the continuous gravimetric mixing line with the lost in weight feeders is the perfect fit. And if I really have very complex recipes with many different components, then only batch mixing is the right choice. As well as if I need a very high accuracy in terms of mixing ratio, up to 1 to 100,000, then the batch mixing line definitely has to be applied. So you see there is a wide range of different possibilities, and it's now always the question which one fits best for your requirements. Then I was referring before a lot to components, and we split them into 4 different categories. We call it micro ingredients. These are the ingredients, the very small amounts you want to add. These are the enzymes. These are the vitamins and so on, or ascorbic acid would fit into this category. So you see, we only add up to maximum 1% of it. Then we have the minor ingredients. These are typical ingredients here would be, for instance, gluten addition, or for instance, salt or sugar for special mixes, but also probably low-grade flour you want to put into a normal baker's flour. So here we are talking about addition 1 to 5%. And then obviously we have the main component. This is the different type of flour which we would add. Now the question is why we make all that so complicated. And the reason is simple, it's accuracy. Because we need to use different kind of scales with different sizes to reach the correct accuracy level to dose all of these components correctly. And of course, there is in the batch mixing process one more component, which is the manual addition or hand component. Whenever you don't use an ingredient often, or when it's something which is very difficult to handle, then you want to put it basically directly into the mixer. Then let's have a closer look at this different type of mixing solution. I start with the most simple one, the continuous volumetric blending system. So usually wise you have the fiber discharger and then underneath the dosing system. In most cases today, these are tubular screw conveyors and then connected to a frequency converter where you then can adjust volumetrically roughly the flow rate flowing out of the individual bean, or where you have the different components where you can mix together. And as an option, very often not used in this sort of blending system is a continuous mixer or homogenizer. Now, what are the feature and advantages of this sort of solution? Well, it's basically mainly there to make the consistent flour quality by blending the same type of flour, or as well possibly the different type of flour together to reach then at the end this consistency. You obviously can add as well other type of products like the low-grade flour, return flour, or you could add as well volumetrically, obviously some additives. Now this is by all means the solution with the lowest investment costs and as well the lowest requirements in terms of building volume. But it has its limit, and the limit is obviously the accuracy in blending and mixing, and this is mainly given by the dosing system, the tubular screw conveyors. When we look into traceability possibility, it is possible, yes, because we know what kind of flour we used at what time we were blending it, and the rough percentage we know as well. So there is a certain possibility given. If we look now in the next system, which is the continuous gravimetric mixing system, we still have the dischargers, the fiber dischargers. We still have the screw conveyors, which are dosing the product out of the bin. But then we have the so-called lost in weight weighers or scales. And we apply them for all the different components. So for the flour, for the main components, for the minor components, but as well for the small ingredients, the micro components. And here now, very important then at the end, we have the continuous mixer to reach the required mixing accuracy or mixing ratio. Today, often as well, we use NIR, online measurement underneath, and obviously mandatory in most cases is as well then the sieving machine at the end. Now let's have a look here at the features and the advantages of this sort of system with the gravimetric continuous blending system. So here, obviously, we can blend together or mix together the different type of flour. We can use with high accuracy and add as well the minor components, such as gluten or the return flour or the low-grade flour. And of course, we have as well the micro components, the small additive, the flour improvers, the vitamins, and so on. Now, this is really, as I mentioned it already before, the ideal production method or solution if you have long production runs. I would say at least half an hour or longer. The longer, obviously, the better, because as I mentioned it, the issue is always at the beginning and at the end. When we start the line or when we stop the line, then we have a small issue about accuracy. When we look then into traceability, here we have the full traceability because we know the exact amount of flour at the time we were dosing it, out of which bin it was coming. And because we have everywhere scales, we have obviously the full traceability available. When we look now at the equipment used in such a mixing line, we have basically everywhere the same type of scales called lost in weight feeders. So they have a hopper and underneath a screw conveyor. All of them have the same principle. The difference is just the size of the hopper and the screw conveyor, but the principle remains the same. And obviously for this sort of accuracy, as I mentioned it already before, we need then as well a homogenizer, a continuous mixer to reach the level of accuracy which is required for this sort of application. And now the question is continuous or batch mixing. I told you before, it depends obviously on the complexity of the mixes, how many additives you want to add, then as well on the mixing ratio. And I give you as well some sort of a guideline when it makes sense as well in terms of investment to switch from continuous mixing into batch mixing. Obviously, if you have only a very few components, very few base flours, and you want to add only one or two minor and micro components, then definitely the continuous mixing line will be the more economic solution. However, if it gets more complex and you have more components, then the batch mixing system gets more economically. When we look now at the different solutions in batch mixing systems, we divide between a so-called 3-section and 2-section mixing line. Now, what is the difference? You can see it very nicely, I think, on this flow sheet. A 3-section mixing line, batch mixing line, has a separate scale for the main components. Whereas the 2-section line, the mixer acts as well as a component scale for the flour. So looking a bit more in detail, we have here the 3-section mixing line. So obviously the first section is the dosing and weighing, so the tubular screw conveyors and the batch scale for the flour. Then we have the second section, which is the mixer itself. And we have the third section, which is then the hopper underneath the batch mixer. So at the same time, basically, we have 3 batches in the line in 3 different positions. So what is here the advantage? It's obviously the higher capacity. Or with other words, we can use a smaller type of mixer to reach the same capacity as we would have in a 2-section line. We then need a bigger type of mixer if it is permitting in terms of capacity. For very high capacity, only 3-section mixing line will reach the required capacity. The disadvantage is obvious. We need more building height and therefore have as well bigger investment in terms of building costs. If we compare this now to the 2-section mixing line, you can easily see here the batch mixer sits on load cells. So it acts first as the scale. We dose in all the flour. We dump in the micro components and the minor components. They need different scales because of the accuracy. We cannot use here as well the mixer as a scale because of that reason. Then this, of course, reduces the building height. And it's as well some sort of a more simpler process, but we do not reach the same capacity, throughput capacity as with a three-section line, or as an alternative for smaller capacities, we simply increase the size of the mixer to get the same throughput per hour. Then when we look at the equipment used for batch mixing plants, obviously we have all the different scales. In this picture, you see now the example of the minor component scale. So the additives are from 1 to 5%. You see here on top the screw conveyors feeding into that hopper. And underneath is simply a flap, which is then discharging the product to the mixer. The scale for the main component basically looks very similar or the same. It's just completely different in size. Then when we look at the micro components, so the very small additives, here we use either as well the lost in weight feeders, or we use volumetric dosers and have a scale underneath. So either gravimetrically with lost in weight and just have a hopper underneath, which then dumps it into the mixer, or volumetrically into a small scale. Then obviously the very heart of the process is the mixer itself. For batch mixing processes, for flour mixing, very common is to use this sort of horizontal mixers. They have the advantage of a very quick and fast process. Usually wise for dry mixes, it takes these 90 seconds. Then it has a very large outlet flap. So very fast, the whole batch is dumped into the hopper underneath, and this is done more or less residue free. They have a very high mixing accuracy. I showed you before, it's up to 1 to 100,000. And there are two options available. Either you have it on load cells, and then you would see now a lot of screw conveyors feeding into that mixer, or as on this picture, it is without load cells, and you see the large pipes coming from the scales above into the mixer below. Then we have to check as well if all of that has been done correctly. And here really online near infrared measuring technology offers a fantastic possibility to measure now the consistency of the flour quality, but also in terms of traceability. We can at any time check what we have produced, if all has been done correctly. And we have as well the option not only to automatically measure the quality, but also to correct certain parameters. For instance, we have the possibility to do a gluten loop. So we can online measure the protein content, and we control now the flow rate of the gluten addition in the mixing line to reach a certain level of protein or gluten. The same can be obviously as well applied for ash if we add a low-grade flour to it, to the flour mix. Here a list of different parameters which we can measure with very high accuracy today with near NIR online measuring. This is obviously moisture, protein, and ash with very high accuracy, but as well wet gluten, water absorption, and starch damage can be measured. You see the accuracy level in SAP with standard error of prediction. The loop function, as I said, is possible with protein and ash. Now, where can it be applied, these sort of sensors? We can simply install it in a gravity spout if we have enough height and if the angle is correct. Then we can obviously install it on a scale, like the picture shows it in the middle. This is a lost in weight feeder, the hopper. We can install it, but we can install it as well in a batch scale. Whenever we dump the product into the hopper, the sensor detects that there is product and it's measuring the quality. But we can also install it directly on a batch mixer to monitor the quality even during the mixing inside the batch mixer. And there is a fourth option, which is now not shown on these pictures. It's the so-called stowing device. This is just a small hopper with a screw conveyor underneath, and the rest of the product is overflowing. This is done wherever the perfect product presentation in front of the sensor is key, because key is obviously always that we have a very good reading from the sensor. This gives us then as well the accuracy of the measurement together with the correct algorithm. Now, towards the end of my presentation, I want to say a few words as well regarding automation. Now, automation really plays a key role in mixing concepts. First, it's about the accuracy. If you imagine the continuous mixing line, you need to imagine that not all of the scales are probably feeding into the same hopper. So if you have different collection points of the products, you need to have the correct timing when which scale has to start, that I mix already at the very beginning as accurately as possible. And the same obviously applies as well for the stopping procedure. Then if you think about the batch mixing process, you only achieve a very high capacity if the timing of each step is done correctly in the best possible way. So here automation really plays a key role. And on top of it, obviously it's then the other aspects, especially in terms of traceability mixing line. This plays a major role, a control system. The question was before regarding what can we do if we have a problem with the dosers. So there are two things which are really important, or aspects which are important. One is it a volumetric or a gravimetric dosing? Obviously, if I have an additive dosed volumetric and the flow characteristic is not correct, it's somewhere blocked, I don't have a control. You have only the control if you have a gravimetric dosing system, because then you get a tolerance alarm if the dosing is not done correctly. And then, of course, the automation system should stop immediately if something like this occurs, that you don't have an issue afterwards. However, if there was once an issue with modern automation system, you can obviously track forward and backward if there was an issue, or if you have a complaint from the market, that you know exactly which batch had an issue. And then there are, of course, a lot of compliance and food regulation and laws which you have to follow in a lot of countries. And here, obviously, a modern automation system plays as well an important role. That brings me to the end of my presentation. At the beginning, I tried to show you what is needed and which parameters are important for the selection of the blending or mixing system. So these are first and for all the market requirements, in which market you are playing or you want to play. Then the number of the different ingredients and the production volume plus the mixing accuracy or mixing ratio is defining then which is the correct mixing system. We divide mixing system in continuous either volumetric blending system with tubular screw conveyors, or in continuous gravimetric mixing with lost in weight feeders. And then we have, of course, very important batch mixing system for all the higher requirements. Batch mixing system, we divide again in 2 or 3 section batch mixing line. The scales and the mixer design, the size of these batch mixing lines, and as well on the gravimetric mixing lines depends, of course, on the components, on the recipes, and on the individual capacities you are looking for. Then I try to explain and show you the importance of online quality control with online NIR measurements, that you have the possibility to at any time check the quality on one hand side, but as well the possibility of corrective actions, at least in terms of protein and ash content, that you can run here a loop system. And at the very end, I tried to highlight the importance as well of an automation system and its advantages in terms of mixing systems, in terms of accuracy, of capacity, but also in terms of traceability. With that, I'm at the end of my presentation. I thank you very much for listening to me, and I'm already looking forward for some interesting questions.
It's an excellent presentation. Thank you very much indeed. I'd like to start with one small question that I have. In order to save building height, can we feed a batch mixing line with a blow line instead of having bins on top of the mixer? And if so, what do you see the risks of that being?
Yes, you are absolutely right. I didn't show that in my presentation, but there is as well a solution that we put the mixing line next to the flour silo, not underneath. The big advantage, obviously, is you save a lot of building height and building costs, but you have the additional relift and the additional energy costs then during the entire lifetime of your plant. That's number one. And number two is you need to be much more accurate than in the dosing, because you have a certain conveying distance and conveying time in your fluid lift. And this you have to take in consideration, especially about all the different flour. So this has to be taken in consideration and done properly, but this is a very common concept.
Thank you. And next question comes, it says, are there differences in mixing times for cakes and other soft wheat products and normal bread flour?
Yes, there is. When I talk about cake flour, I think we have to be careful. When I say cake flour, then I mean the convenient product, the ready-made mix you buy in the supermarket, which has most of the ingredients already inside. So if you talk about this sort of product, then obviously you have a lot of different additives which is needed to get this ready mix. If you compare it to baking at home, if you make a cake, you have probably 10 or 20 different ingredients until you have your cake. And this has to be taken as well into consideration if you have this sort of mixing line. First of all, you need a lot of space above the mixer to store all these different ingredients. That's number one. Number two is you need to be careful what kind of ingredients you're using. Before was the question as well regarding the cleaning. If it's a simple mix with not a critical ingredient, you can flush it, no problem. But if you talk about, for instance, a chocolate cake where you add chocolate powder, or a banana cake which has a very strong flavor, you have to be very careful that you clean afterwards thoroughly. So then usually the mixing line becomes much simpler. You basically have a mixer dosing just the main ingredient, which is the flour and maybe the sugar and maybe one or two main ingredients. And all the rest is done by hand tipping. And the underneath is directly the packing machine. The reason is simple, because then you save so much time in cleaning, whereas if you would have a fluid lift, you would need to take all the pipes apart and clean everything, which really makes no sense. So yes, when we look into these convenient products, then there is a major difference, not in technology, it's still the same type of mixer, but we need to be much more careful how we set up the plant and how much time is needed then in terms of cleaning versus the time I save if you have a more automated system.
Thank you so much. The next question is from Ali Tavane, and he asks, are there any specific mixed products that use gas or liquid form ingredients required to be incorporated into the flour?
Yeah. If we talk about liquids, it's mainly oil addition. When I referred before to cakes, usually wise they have a certain fat content, and fat can be added either in blocks, and then you need, apart from the pedal inside the mixer, you need so-called, we call it chopper knives, so fast turning knives, which then cut the block fat, but cuts as well the lumps which you create during mixing. The same applies as well when you exceed a certain amount of oil which you inject into the mixer. So yes, there are liquids. If it comes then to gas, all I know it's that nitrogen can be added for very specific mixing. If the melting temperature of the oil is too low and it becomes liquid again, that you may inject some nitrogen. But this is in mixing very, very rare, what I have seen so far.
Thank you. The next question comes from Solutica, who asks, will consistency of flour be achieved by use of tubular screw conveyors without paddles?
Yeah, the tubular screw conveyors, they are just the dosing element. So that you have, for instance, from 3 beans, 1/3 of the capacity is coming from each individual bean. And then the mixing has to be done afterwards, either with a pedal screw, or if you believe for your requirements, the control sifter and the fluid lift afterwards will do the blending sufficiently, like it is done in many cases, actually, if it's a very simple continuous volumetric blending line. Obviously, if you have then additives which require a higher mixing accuracy, so the dilution of that additive has to be done more accurately, then you need an additional homogenizer who helps to do that. But the screw conveyor, which is dosing, has a normal full flight.
Thank you. The next question, there are only 2 more, asks, what would you recommend in regard to mixing ingredients with different bulk densities in regard to dosing elements and conveying the finished product?
Well, the dosing obviously is not the issue. If they have different densities, it's the problem if you have a segregation afterwards, again in the bin. So there you have to be very careful. It's the density is not so much an issue, it's more the particle size is an issue. So if you have coarse sugar you're adding to a mix, it could be easily segregated. Or if you add coarse bran to a mix as well, that can easily segregate. So it's more the particle size than the density itself. If it's all nicely powder and similar granulation, then usually wise density is not so big issue.
Thank you. Sorry, we have 2 more questions now. Thank you for your presentation. This is from Mr. Ayu Akinwande, who says, thank you for your presentation. For the inclusion of minor components of 1 to 5%, can the minor components dosing system be incorporated to an existing mill?
Well, into a mill, yes, we can add as well there. Higher volumes, obviously, can be done. That you mix already the gluten or a low-grade flour in the mill. Theoretically possible. You then need the lost in weight feeders. And obviously as well, the transports afterwards have to be sized accordingly. If you add let's say another 10% or 5% of your flour already in the mill. We have seen that, for instance, return flour or products like this have been added already at that stage of the process. It's possible, yes.
Thank you. And the last question from Mr. Ahmed Al-Saman. Is there a higher tolerance range on the batch mixer with load cells comparable with scales, or will it still act the same?
It still acts absolutely the same, but I tried to highlight the importance that we divide the different components into these minor, main and micro components. As long as the mixer on load cell is sized correctly and the load cells are sized correctly, we achieve the same accuracy as we would have a separate scale.
Excellent. Thank you, Peter. And thank you for a wonderful presentation. Thank you, Mr. Milan.